This is Algebra 1, Lesson 96. This is graphing quadratic functions. Now, a couple of things we need to start with, and this will be a little bit of review for most of us, and that is, what is a quadratic function? Well, this is the standard form of a quadratic function. This is the f of x, or the function of x, equals ax squared plus bx plus c. We've been using these quite a bit. We've factored them. We figured out how to rearrange them, put them in standard order. Way back in the first couple of lessons of the book, we even found out the degree of the polynomials. And these quadratic always have a degree of 2, right? And that would be that number there is standing for. Now, a couple of things that when we go to graph these. Yes, your calculator does a wonderful job of graphing them, and we will get to that yet today. However, being able to graph these by hand is very, very important. And you're going to understand parabolas much deeper when we start graphing these quadratic functions. So then that's the shape that it always forms, is quadratic functions form parabolas. And let's talk about how that works. In order for it to be quadratic, it goes x2, x1, and no x. And we also have some things we need to define. The first is the axis of symmetry. If I said something is symmetrical, what that means is it's the same on the left and the right side. The human body is symmetrical vertically, or very close to it, right? When we look at it, the same on both sides. And we understand that has an axis of symmetry, which means if I could get one half of it, I could therefore mirror the other side, and I know what it looks like. So the axis of symmetry, there's a formula for finding this, and it always works out of this formula here. X equals negative b over 2a. And that means that we need to understand what these terms are. This is my a, there's my b, there's my c. And these are the numbers, the coefficient numbers out front for a and b, and then the non-variable or the constant number for c. So when we look at this, we realize that if I know the axis of symmetry, well, something else I noticed, and that is what the definition of what a vertex is. A vertex is the point which is either a minimum or a maximum. If the parabola opens upward, it's the point that's the very bottom. If it opens downward, it's the point at the very top, right? So if it opens upward, it's kind of like, where would water settle in there? That would be the vertex. The axis of symmetry always passes directly through the vertex, which means that we know the x value by simply knowing what the axis of symmetry is. That x is going to tell me exactly where it passes through. So I know the one value of the vertex, and then I can plug that back into my equation to find the y value, because I already have the f of x as my y value. Now, let's sort of talk about some other things here. If a is positive, the function opens up. If a is negative, it opens down. Well, that's easy. If a is 0, it's not quadratic. That's really simple. C is the y-intercept. This is where it crosses the y line. That's the vertical line. Okay? And sometimes you're going to see how that is useful, and sometimes it's not, because if the vertex happens to be on the y-intercept line, knowing that that crosses there is kind of redundant. We'll see this here in a minute. Example 1. Graph the function y equals x squared plus 4x plus 5. First thing I have to do is start labeling things. Well, what is A? Well, A is 1. What's B? B is 4. C is 5. Now I have these labeled. The next thing I do is I start, from that labeling, I start with my axis of symmetry, because I know that it's going to cross through the axis of symmetry, the vertex is, or the axis of symmetry will cross through the vertex. Therefore, if I can find where that axis of symmetry is, I already have a big point down, right? So let's go ahead and do that. X equals negative b over 2a. Well, what was b? 4. What was a? 1. So it becomes negative 4 over 2 times 1, which gives me a value of negative 2. So in other words, I know that this is going to graph on the vertex, or the axis of symmetry will be at negative 2, 1, 2. And there's my axis of symmetry, that dotted line I put there. I know that the left-hand side of the graph is going to look exactly like the right-hand side. So I need to be able to take this and figure out where that vertex is on this line. Well, because I know it passes through there, I'm going to take this negative 2 and plug it back into here. So negative 2 squared plus 4 times negative 2 plus 5. And I've done that right here. Negative 2 squared plus 4 times negative 2 plus 5. Negative 2 squared is 4 minus 8 plus 5, which is 1. So once I know that's 1, my vertex is at negative 2, comma 1. Negative 2, comma 1. This is getting more and more simple. I know it opens upward. So if I was going to graph this again, to show you, I would go back 2, right, up 1, because I know that that's where it's going to go. And I put these little tails on it like this. I don't know exactly, because it could open like this, It could open really steep. I just know it's going to go through that point, and it's going to open upward because a is a positive number. So the next thing I do is I need some other points. Now, what I also recognize here is that C is the y-intercept. Well, what is C? C is 5. So if I come up here to 5, 1, 2, 3, 4, 5, and put a dot, right, I know it's going to cross through that point. Sometimes that's all you need, because I can see that it's going to have to go through here and come back, and that's exactly what I did, and that's how I graphed this. However, other times you may need one more point or two more points, and it doesn't hurt to do so. I chose to use 1, and so did the book, which is useful. So if I put 1 in for x, and we're just like that old chart we would have made, right? When I put x in, what's y? Well, when I put x as 1, 1 squared is 1, plus 4 times 1, which is 4, so I have plus 5, which is 10. And that means that when I'm up over here at 1, it's all the way up here at 10, which is off of my graph, but you can see that that's exactly where that would be. So that I can very easily graph the one side and then just duplicate it for the other. That's the easiest way to graph parabolas. Now, let's move on to another example here. I've got y equals 5x squared plus 4. There's a problem when I go to graph this. What's b? I'm going to rewrite this with a 0b function. Can I add 0 to something without changing its value? Well, by definition, yes. So I'm going to put that in here as 5x squared plus 0x plus 4, and then label it. A is 5, b is 4, or b is 0, c is 4. I know that a is a positive number. It opens upward. I go to put my axis of symmetry in, right? And so I say negative b over 2a, because that's what we learned just a second ago. But I've got a problem. When I put in a negative 0 and divide it by 10, I end up with 0. The axis of symmetry is 0. Well, that means that it's crossing through. And I did exactly what I told you to do on the first one here. And that is I put my little tails and I said, I know it's going to open up, but it's, I don't know where now. Because this is where all of a sudden, knowing that the y-intercept is 4. Well, the y-intercept being 4 happens to be the axis of symmetry and the vertex. Because when I put that in and I say, well, put that in for 0 for x, I end up with 4 again. So all I've got is 1 point from 3 steps, and that's not helping me any. I know it's at 0, 4. That's a vertex. I know it opens upward. So I need to plug in another point. If I chose 2, 2 is a nice number. I like to stay positives, right, if I can. And I put 2 squared, which is 4, times 5, which is 20. 2 times 0, remember I put my 0 term in there, it's still 0, plus 4, and I end up with 24. And it looks like I skipped that even though I graphed it, right? There's my 20 plus 4 is 24, not 4. If I go ahead and plug that in and I realize, well, where would that be? That means if I go over just 2, I'm all the way up here at 24. Well, that's all I need. I need that half of the graph to go ahead and put my rest in here as an axis of symmetry. That's pretty simple. Now, let's go ahead and move and shift gears into a little bit. This has all been doing it by hand. What if I want to use the calculator? And you'll have to bear with me as I show this, because it is going to be a little bit more cumbersome with me pushing buttons here and then showing. So I went ahead and I put in, for example, find the zeros. Now, first of all, let's talk about what zeros are. Zeros are the point at which it crosses this axis, right? The y-intercept is when x is 0, but I want to know when y is 0. This one doesn't have any. This one doesn't have any. This one has 2. And sometimes, so there's 3 different ways that I could have zeros. I could have no zeros, right? I could have 1 0. That would be if it just came down and touched it and came back up, or came up and touched it and went back down, right? Those would be 1 0. Or I could have 2 zeros, and that would be either whether it's open up or open down. It doesn't matter, left or right. But you can see I have 2 zeros on either one of those graphs. Now, therefore, I'm going to use my calculator to determine the zeros. So I have my first equation, y equals x squared minus 6x plus 9. Now, some of you are going to recognize that this is a perfect square trinomial, and perfect square trinomials only have 1 0, which you're going to see in just a minute. I went ahead and plugged this in and said x squared, by using my x key, bring it to the squared function, minus 6 times x plus 9, and then I hit graph. Okay? When I hit graph, it graphs out that right there. And you'll have to ignore the fact I already put in the other 2, but I didn't graph them. Now, the number of zeros is just like what I said with only 1. Notice it's only touching once. It's opening upward. Is that logical? Sure. My x value was a 1, and it's positive. It opens upward. Okay, it's going to cross at 9. Well, I can't quite see it, but yeah, it looks like it crosses at 9 up there. So the next thing I need to do is find the zeros of this function. In order to find zeros, I have a key here that's going to do this for me. And the book doesn't show this very much in detail, so you'll want to watch very carefully as I do this. I'm going to hit the second button, okay, that's using a little up arrow, right? And hit this one that says trace or calc, okay? That's going to give me this menu here. When I jump down, I want to find the 0. Now this would also find minimum, maximum, intersect, all that good stuff, but I want to find the zeros. And then it comes up, and I'm not sure how well you can read that, but it says left bound. What that means is it wants to know, where do you want to start looking? Because calculators aren't as smart as what we like to think. It's going to have to start at a certain point. Why? Because this graph goes infinitely this direction, infinitely that direction. And because of that, where would it start? Well, if you said, find out where it crosses, it would just keep trying over and over and over, infinitely looking, even though it wouldn't be logical if it was going away for it to find that. So it needs a left bound. And we're going to just move the arrow over here, and I'm going to show that. It's got a little asterisk. That little asterisk is showing, hey, this is how far over I went to the left. It doesn't matter as long as I am to the left of where I see that y-intercept. Then I hit the enter key, and it's going to say, what about your right bound? Where do you want your right boundary to be? And I go over the intercept there, okay, over the 0, anywhere over here. It doesn't have to be even, it just has to be where I'm saying from here to here is what I want to check. And I hit enter again. And then if you look in the bottom corner, it says guess. Now the reason it's saying guess is it's going to try every value. Now this is not going to be perfect, and I think we're going to see that here. And I hit enter on the guess, and it's going to say 2.99994. Now why did it stop there? Because the real answer is at 3. Because if I